So for end behavior 15 and 16, I think we're going to do 15 through 18 in this video. So you want the end behavior of this. Now, hopefully you understand that when you look at a polynomial, now this f of x is also y, all right? So f of x equals negative x to the 4. Now, when you want end behavior, this power and this sign right here totally dictate the long-term behavior of this function. Okay, now this could model anything. It could model winning patterns of a baseball team. It could model the number of dinosaur artifacts discovered in a particular region per day. Like it could mean anything, right? But the end behavior kind of determines where is it going to go in the long run, okay? In both directions, to the right and to the left. So what you have to remember is that these arrows kind of give you an idea of what's happening here. So if this is a negative and that power is even, then it means that ultimately this guy on the left-hand side started negatively. He did some stuff, okay? He went up and down and did all kinds of motions, and then came back down. All right, that's what he does ultimately. All right, and we didn't even do any math to it. We just saw a pattern, and we just recognized the definition and knew that it did this. Now, what this means then, okay, and I'm going to go ahead and actually split this up because I think this is kind of a source of confusion. Maybe you guys get it already, but there are always two arrows. This is as x goes to negative infinity. I'm going to darken this up here so that we can clearly see that. We got two groups here. But the left is always as x is to negative infinity. This is just a fancy way of saying a left arrow, okay? So notice as x goes to negative infinity happens in the first line of each multiple choice. That is the left arrow, left arrow, left arrow, left arrow. And when you go look over here, that's the right arrow, okay? Going down one, that's the right arrow. So each one of these is the left arrow. I said left again, I meant right arrow. Okay? And all of them have the same thing. All of them. As far as this x goes, they all have the same thing. Alright? You always do left, then you do right. Left, right, left, right. What you have to pay attention to is the f of x. The f of x is the determining ingredient. Okay? This says f of x is going up. So f of x is going to positive infinity. This guy is saying f of x is going to positive infinity. Alright? And so on and so forth. This guy says f of x is going to negative infinity. This guy is going to negative infinity. Why? Because he's going down. These two are going down, so it's negative. These guys are going up, so he's positive. And so on and so forth. All right, so if I have a negative even, what it means is I go to this pattern and I see that with the left and the right, they are both going down. So I'm looking for two negatives. Right there at C. All right, same thing applies to 16. We have a negative odd. So we go here, and now a negative odd, that is an up arrow, so I will say that f of x is going to positive infinity, and this guy is going to negative infinity. So I'm looking for this. And f of x is positive on the left arrow, f of x is negative on the right arrow. Okay, so he is positive on the right, but nope, that's positive on the, I'm sorry, positive, that's a positive positive, that's a positive even. This guy's a negative even. This guy starts off at positive to the left, negative to the right. So this is my guy right here. All right? So that's all for that. Okay, now this is different because here we just looked at the highest degree and notice that we had addition and subtraction between them. Here we have multiplication. So I noticed while you guys were working on your study guides over the last few days that you looked at this and took the highest degree and thought it was odd. All right? But what you've got to do is, in this case, because you're multiplying here, you actually have to add all of your degrees. Now, if you see a linear binomial, the degree is 1. This is a cubic and that is a quadratic. So you have to add these up, and you'll find that it's a 6th degree polynomial, and it's negative. Now, a 6th degree negative means that the arrows will start up to the left and go down to the right. All right? So we're going to have up to the left and then down to the right. Okay? So that took care of the negative. Now I do not have an x in front like I do over here. All right, we'll take care of him later. But right now what I'm going to do is I'm going to put dots. I'm going to put mark points at each one of these zeros or each one of these roots. So that's positive 2 would make 0. So I put a point there. This negative 3 would be here, and then a positive 6 would be here. And what I do is I look at the multiplicity on each of these roots to determine the behavior at that root. Do I bounce? Do I brush? Do I just pass through? Those are the 3 major things. The higher the degree, the heavier the brush or the heavier the bounce. But if it's just one first degree, like this, you'll just pass through. So here we're going to have a bounce at positive 2. We'll take care of him. I want to look at this guy since I'm starting from the left. So what happens at negative 3? Negative 3 is to the 3rd power, so he's going to have a little brush. Okay? And then he'll come back down. Now, it does say possible. Now, the possible means that I don't know how far down he goes. Sometimes these things will go straight up, have a little bump, and then go straight through it. Like, it looks like literally they're going to go all the way down, and then just kind of, it's, when you graph these, it's pretty tricky. Or when you graph it on a graphing calculator. But the next one actually happens at 2. All right, so we have a bounce at 2. So we come up. We have to come back up and bounce off of 2. We're not going to pass through. We have to bounce. And then at 6, he's going to just pat. Oh, I feel like I screwed up. Started. Oh, that's why. It's 6. Arrow has to start there. God, this. Okay, it's got to be in green. All right. Okay. Can't delete this video. All right. I'm not going to delete it. So, yeah, so you're probably screaming at the computer for the last 2 minutes. All right, this is a negative even, so then the 2 arrows go down. So what happens then is I pass through here like this. See, because when I bounced off, I saw that it didn't match with this. I knew something was up, something's wrong, and it didn't work out right. So then I knew something was up. Okay, so actually maybe this is a good learning lesson for all of us. Or I should have known better, and you are just mad now. So what's going to happen here is we are going to bounce off of here, and then he'll come back down and pass through. Okay, now the 2 arrows will reach. Before, didn't make any sense. All right, so that's your final answer. All right, so I'm going to, let's see, I'm going to count the degrees. It's not negative, so 1, 2, 3, 4, 5, 6, 7. This is the 7th degree, and it's positive. So it is a positive even. I said even. Positive odd. And we're going to put our zeros in at 0. Okay, when there's no parentheses and you have an X out in the front, you're at 0, but you will have a bounce there. Okay, and now we have one at negative 5, one at negative 3, one at positive 6, and one at positive 7. Okay, so a little tight fit here, but we're just going to manage these carefully. So it looks like I have a down arrow here, and I will have an up arrow there. Okay? So what happens at 5? 5 is just a pass-through. Okay, but it happens quickly that I have to come back down to negative 3, and he'll bounce. So he'll bounce. And then at x to the 2nd power, he will also bounce. Okay, and this guy can go as high as I want it to. It doesn't matter. All right, but then at 6, it looks like he will pass through. Okay, and then at 7, he will also pass through. Okay, so something like that. Maybe it should have looked more like this. No, more like that. Doesn't matter. I would have accepted either one. All right, so that's pretty much it for that. All right, we'll stop there.